in my background. Okay, Hamid can hear me. Ayodeji and David, if you can hear me, please give me a thumbs up. All right, thank you, David. Um, all right, guys, I'll start by presenting my screen so you guys can see what I do, what I'm doing, basically. So, yeah, I'll just start with the, yeah, excuse this mirror thingy. I'll just start with the presentation here. So, what we are doing today is advanced SQL concepts and final projects for this SQL series. And yeah, so the objectives of this session is views, stored procedures, and triggers, and how to implement views, how to implement stored procedures and triggers for automation. So I'll just go right into it. So views are, so when you think about views, or when I first learned what views were or views are, I thought about it as a saved query. So I wrote here that a view in SQL is like a virtual table that does not store data itself, but it pulls it out from other tables in the database based on the query. So it is a way to look at specific data from one or more tables without duplicating that data. So I'll just first explain that. You know, knowing that we did or we took database design last session, we talked about how to design our database, how to make sure they are in the right form, 1NF, 2NF, 3NF. And if you can remember, you know that you can't put all the information on one table. It has to be stored properly. It has to be, you know, it has to be stored properly, basically. And you can't put all your information in a table. So if you cannot do that, what if, for example, there are some times when you need to do the same kind of query every time, where you need to join from one table to another. So instead of joining every time, you can just join and then save that query. And that is really what a view is. So instead of creating a new table for every custom data reports or read reports, remember when I talked about read and write operations? So every time you want to read a report, you have to join. You don't have to really do that. You can always create a view. So um, creating a new table for every custom data report or for analysis of specific subsets of data, you create a view that only shows the columns or rows that you care about. So instead of always saying, oh, select this from this, join this, where this is this, you can always can create a view, and then when you need it, you can just call out for the view. So I wrote here that the create view syntax is used, followed by a query. So once created, you can access it using the select from syntax name or view name, sorry. So now I went further to say that you might want to ask me that what are the benefits of view when I can easily just still do my joins and I won't get confused by views and all of that. So you need to, or you would like or you would want to use views because there are no data duplication. So views does not store data here, like I said before, and they dynamically retrieve it from underlying tables or a table whenever you query the view. So this saves space, this eliminates redundancy. For example, if you want to select data from maybe two or more tables now, when you select that data, you might want to update something, and that would start to cause you um to duplicate data, and that's really bad for our database, like I've told you in the last session. So the second reason is simplifying complex queries. So views allows you to store complex queries so that users can retrieve data without needing to understand or rewrite those queries. There are some CTEs or there are some joins that you see and you'll be like, ah, how did they do this one? Or Sometimes you can even be lucky and you do it once, yeah, and you don't want to go through that stress again. So you just create it as a view so that later when you want to use it, you just call out the name of the view instead of going through those complex queries and stuff. So the third reason is for easy maintenance. So if you update original tables used to create the views, those changes are immediately reflected in the view. So you don't have to worry about keeping multiple tables in sync. Yeah. So because we're going to do a simulation here, yeah, like we always do. So instead of always what's the word now? Instead of always going back to change some things in your table, because you are always taking values from the table that you use in your views. Anytime you change something in that table, it will automatically change in the views because that's what the view is using here. All of this will be understood when we do it in our MySQL. I urge you to do it as I'm doing it too here. But if you can't, I will always share the SQL scripts after the class. So the first reason is data consistency. So by using views, you can ensure that users are always seeing the same consistent set of data, even if the underlying tables or data structure changes. So even if, for example, your view contains selects this from this where cost is 20, when you change your table, maybe you change the data in your table and it's already 30, there is no 20 there, and the list value is 30. When you change when you want to use your view, it will automatically change by itself because obviously what you use in your views is in the table. So your view cannot pick something from somewhere else that was not in the table. So everything your view represents is in the table. That's what I'm just basically saying. So I'm going to go to SQL Server now and I'm going to um, do what I've been saying since this is just a screenshot of one of the syntax in case somebody is reading the slide and they need to understand what I'm talking about. Yes. So before I go on to SQL, I would, if you understand what I've been saying since, please give me a thumbs up. If you don't, I will try and say it or try and explain again. But I feel like you understand more if we go to SQL Server and I say SQL Server, MySQL, and we do what we have just talked about. But if you don't understand, I can maybe give more examples so you understand. I just need a thumbs up so I can go on. All right, thank you, Hamid. And thank you, Ayodeji. Thank you, everyone, basically. So going back to this, I'm using the same scripts we used in the last class, the Parks and Recreation database that we created, and all of that. So for those that were not in the last class, we created a database, Parks and Recreation, created a table under that database called Employee Demographics. We created table Parks Departments, which has all the departments under it. The Employee Demographic has all the information about the employee ID, first name, last name, age, gender, birth dates, and the primary key is the employee ID. While the employee salary table had employee ID, first name, last name, occupation, salary, and department ID. The foreign keys here are employee ID and department ID. And we put in data into the employee demographics, the department, and the salary. We also did indexes, yeah, where we created indexes and we saw the difference between using an index and doing your query just like that. And so today we're using views, and this is where we're starting from. I already pre-populated the script, yes, so I'm just going to explain what the syntax is. So like I said before, the syntax for use creating view is create view. Yeah, it is well explained or it is self-explanatory. So create view followed by the name of the view that you want to create. So and the name of our view is employee basic information. And we want to get basic information of the employees more than the ones that we have in the employee demographics. We want to get basic information about our employees. So we say create view, the name of our view as, then we go on to populate our view. So select employee ID, The employee ID is in the employee demographics. So your normal join syntax, the first name in the employee demographic, the last name in the employee demographic, the age, gender in the employee demographic. The occupation is in our salary table. The salary is in our salary table from employee demographic as D, joined to our employee salary as S on the employee ID, which is a key that they both share. So the only different thing here is this is your normal join here, and what we just do is we create our view and we use it. We say this view is going to be as this syntax. That's the only difference. So we're going to go on and drop database if exists and start again, like I always say. And for people that are just joining us, drop database is very important because it basically just says that if this database exists before, drop it and create it again. You can always create it again. So let's just do that because I have done some things that shouldn't be there. I want to start again. Yeah, so because of people that are just joining. Okay. I keep going. Okay, let's just stop here and do that. So everything is done. Yeah, so we can now start creating our view. We can now start creating our view. So create view, select from join on, and we just do that. And as you can see, our view creation is successful. Yeah. So how do we use this view after creating the view? So what's the point? How do we use it? So when you want to get data, because if you want to keep doing this, it will take time and it will stress you. So instead of keep doing select from join when you want to get employee basic information, yeah. Instead of doing that, you can just make it a view and then you can always select. So you do select all from the view name because we already named the view as this and we said this is the view, this is employee basic information. We're running this syntax as employee basic information. So now we're going to select all from employee basic information. So when we do that, it gives us what employee basic information is, which is the employee ID, first name, last name, age, gender, occupation, and the salary. So you can see that creating view is straightforward and it simplifies a lot of things for us. Yeah, so we don't have to keep doing things over and over again. So this is another so the first example is employee basic information. I already commented there so you know what the syntax is for. So the second one we're going to try is female employees in high paying jobs. So we're creating view as always and we're naming the view high paying females as. So our syntax is we're selecting first name, last name, occupation, and salary from employee demographics. And we're joining it with employee salary on the employee ID in both tables. And we're saying where the gender is female and where salary is greater than 50,000. So keep in mind that what we're looking for is high paying females. You want to know the females that are paid well or that are paid high. So more than 50,000 means they are paid high, and gender equals to female means we want females only. So we're creating the view, and the name of the view is high paying females. So let's create the view now. So as you can see, our view is created successfully, and so let's use our view here. So select all from the name of the view, high paying females, and we do that. So we select the first name, the last name, the occupation and salary of females that are paid greater than 50,000. So that's just basically it. So another example we're going to use is we're going to create view to count employee per department. Yeah, so we want to know how many employees are in each department. And you know that the employee demographic table and department table are two different tables, so we have to join. And the funny thing is, the department name is under the department table here, and the employee name is under the employee table. And so we need to do two different kind of joins. That's what I'm just basically saying. And so I'm just going to take you through how I did that. So select department name. Department name is under the department table. That's Parks Department, and it's written as P. So department name under the department table. Then we are counting the employee ID as employee count. We are counting it. Employee ID is under the department demographics. The employee demographics, sorry. So we're getting we're selecting the department name from the department table, and we're counting employee ID from demographics table. And we're doing that from employee demographics as we're joining employee demographics to the employee salary, because the two things they have in common is the employee ID. But we cannot join if we had something in common with employee demographics and department, we would have joined it directly. But because we don't have anything in common with employee demographics and department table, so we have to first join employee demographics with employee salary by their employee ID, then join that with the department table by department ID, because the foreign key in employee salary is the department ID, but the the demographic table does not have department ID as a column, because we already talked about it in the last class. Because of 3NF, we can't put a non-key attribute in the same table as that. Yeah, so people that were in the last class would understand what I'm talking about. But yeah, let's just go on. So to explain again, department name, count of employee ID from the demographics table. We are joining it with the employee salary table on employee ID, which is something they have in common. Then we are also joining it with the department table using the department ID, which is something the department and the salary table have in common. And we are grouping it by the department name because we want to know the number of employees that are in each department. Yeah. So having said that, so I will just create the view. So as you can see, our view is done successfully. So using it, we're just going to select all from our department employee count, which is the name of the view we just created. So we can see Parks and Recreation is one of the departments, has 7 employees. Public Works has 2 employees. Healthcare has 2 employees, and Finance has 1 employee. So that's 12 employees in total. So that's just what views does. Yeah, it just simplifies. So each time, if you want to use views, like you want to use this particular grid operation again, you don't have to write the join all over again, or you don't have to start copying and pasting. You can just, since we already gave this syntax as department employee count, all you have to do is select all from department employee count. So that's what views are all about. So if you understood what I just explained, please, or if you have any questions, you can do so, because we are going to start procedure next. So if you have any questions, please let me know, or if you understand, give me a thumbs up. Okay, Ayodeji is raising his hand. Do you have a question? Please ask.
Yeah, good evening. Sorry, good afternoon, and thanks for the teaching. So can you please like visualize like one of the tables? Can you change maybe a row or something, and like let us see what it brings?
Can you speak up a little? I didn't hear what you said.
Okay. So yeah, I was asking if it's possible to, when you explaining, you said that even when the data changes, the view will still bring like the most updated data.
Well,
So
okay,
from the
yes,
table, yeah. So I was
that's
asking if you
true.
can like change something in one of the tables. Like let's see it before you
Okay, we
change,
can do
and
that.
then let's
We
see it
can
after.
do
Yeah,
that.
yeah.
Okay, I'll try to do that. Yeah, but the the basic explanation here is that if you used department employee count as this, yeah, you're saying, oh, department employee count is this syntax. So if we change something in maybe department name now, because what we grouped by is department name here, and what we have here is department name. So if we peradventure change something in the department, it's not selecting the department name itself. It's not selecting maybe public health. Maybe I don't know what one of the department name is. It's not selecting parks and departments itself. It's selecting department name here as the column. So whatever department name is what is going to return. So whether you change something in department name or you change anything in the table, it's going to update automatically, like I said, because is not pointing out to the specific department, it's pointing out to the department column. So let's try to do what you said. Yeah, let's try to do what you said. So this is the let's use the department. So this is the department. Let's one of it is parks and creation. Let's leave it as maybe Bolu Parks. And let's, because we have to do this again here because it's going to probably give us an error. If we don't want to give it an error, we're supposed to use like an update syntax. But I want to change the department itself so you can see what I'm talking about. So let's just run this. No, let's not create view yet. Let's just stop here and do that all over again. So we have changed the parks and department to Bolu department. So we see if it will update itself when we use the view. So the view we used then was, yeah, employee counts. So let's create this view now and see again if it's going to return. So we created the view here, and so select all from department employee counts. So as you can see, it's no longer parks and recreation. It's now Bolu Parks. We already updated the we already updated the one of the values in the department's table, and you can see the view is returning what we updated already, and that's really what I'm talking about when I say that since your view is populated by that syntax, it's not pointing out to a particular department name, it's pointing out to department name as a column. So it's going to return anything that is in the department name or whatever is in the syntax. So yes, thank you, Ayodele, for that. Because if you didn't do that, you will not really understand what I meant by when you update, it will automatically um, update itself. So let's just go to. So we've talked about views and how to implement them. So stored procedure is the next thing in line. So stored procedures are a set of pre-compiled SQL statements that are stored in a database and can be executed as a single unit. They allow you to encapsulate complex logic and repetitive tasks in a database. So they are especially useful in scenarios where the same operation needs to be executed frequently or where complex logic needs to be maintained in database. So I'm just going to explain it like this. When you start to work here, maybe you start to use SQL a lot, it's not going to just be SQL select from where. It's obviously going to be a lot and tons of um of queries here, of syntaxes and all of that. And you even get tired of doing things over and over again. So you're going to look for ways here to minimize um this 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 syntaxes that you use every time. You want to have a way of simplifying them, of automatically doing them. So this is what views, stored procedures, and triggers really are. And stored procedures, as we read here, are just they are useful in scenarios where the same operation needs to be executed frequently, yeah, or where complex logic needs to be maintained in database. So the basic syntax for stored procedure is create procedure and then the procedure name. To execute a stored procedure, the syntax is called procedure name. In other database management systems, they use what was this thing I was using before? Before now, I wasn't using call and it was giving me an error, and I was wondering why. And that's because I was used to SQL Server. I think that one is execute. Yes, the syntax for executing a stored procedure in other in SQL Server is execute, but in MySQL, which is what we are using now, it is call procedure name. So, like I said, yeah, the note is the syntax varies from database management provider to database management provider. So that being said, I'm just going to highlight the key features of stored procedures. So it improves performance just like views. Yeah, they are optimized by the database engine, and this can lead to faster execution times compared to running individual SQL statements repeatedly. You can reuse them once they are stored. Once the stored procedures are created, they can be reused multiple times without rewriting the SQL code. That's the point. You don't have to rewrite anything. And parameterization is you can accept parameters. Now, unlike views, stored procedures can accept parameters. You'll see what I'm talking about when we do it in the MySQL interface. So it allows you to pass values to them without calling. This makes them flexible for different use cases without modifying the underlying code. Now, security. By using stored procedures, you can limit direct access to the underlying tables. When you don't want everybody to be accessible to the tables, you can easily just do stored procedures here. What they will just see is the name of the procedure, and they can always call from it, but they don't have to see the underlying tables you use to create the procedure. So that being said, we're going to go to like I said, we're going to go through MySQL to do what we just said. But you might want to be asking, oh, so what's the difference between views and stored procedures? But that's also what I asked too. So views are primarily used to simplify data retrieval. If you were in my last class, I talked about read and write, yeah, operations, and how I said read operations are data retrieval operations like select from. I want to see what this is. But write operations are when you want to add or modify to a database, like insert, update, delete, all those kind of things. They modify a database. You're not reading anything. You're not getting any outputs. Yeah, you're not reading any table, but you are writing. You are modifying. Those are the different operations we have in a database management system. So we are saying views primarily use simplify data. They are used to simplify data retrieval. While stored procedures, they perform a variety of actions, not only data retrieval. They also perform data manipulation like insert, delete, and like what I just said now. So views are executed as part of a select statement. When you query a view, the underlying SQL query defined in the view is executed and the results are returned. But in stored procedures, they are executed using the call command. Yeah, you can't just say, oh, select um, um, this view. You can't just say select this stored procedure. You have to call the command because it's very different from this, and you're going to see that. Views do not accept parameters, like I said in the key benefits of stored procedures. They don't accept parameters. Once they are defined, you use it like that. But stored procedure, they accept input parameters, and it makes them very flexible and reusable for different operations. You can pass different values each time, and you can execute when you execute a stored procedure. So let's just go to MySQL and see what I've been talking about. Yeah. So we're starting with stored procedure. And okay, before I do that, let me get feedback. You guys understand? I'm sure you might not really understand the difference here until you see how it works in MySQL. But if you still get what I'm saying, please just give me a thumbs up or say something. So I know that you're following. All right. Thank you so much. Thank you. So let's just go on. So stop procedure. Stop procedure is, how do I put it? Because stop procedure is different from views in the sense that with the views here, we just get the syntax and we call it a name, we create a view, we name that view and we call it that syntax. But with stored procedures, it's like the name implies, you are storing a procedure. It's not just one syntax, it's like a procedure, yeah, and you are storing it. For example, to start, you have to make your delimiter or change your delimiter to this. Now, the delimiter in a SQL server is obviously this semicolon. Yeah. That delimiter means when you finish your query, what you add to it to signify that you are done with that syntax or with that query. It is a semicolon. But before you start creating a procedure, because your procedure will have different kind of different kind of syntaxes, yeah. And if you don't change your delimiter to this, if you keep using this semicolon, and for example, you use a semicolon here to, I'm sorry, it will probably give you an error because it's be looking at, oh, you've ended the syntax here. Why are you having another delimiter here? This cannot be just one syntax. So delimiter changing just helps you to not have an error, basically. Yeah. So before you start creating your procedure, you have to define that, oh, delimiter has been changed to this, which is this double dollar sign. Yeah, I'm just going to change this semicolon to double dollar sign. Or let me just use it so you understand. But let me use it. Let me. So, yeah, let me go back to that. Okay, that being done, let me explain what this syntax is. So before, like I said, before creating a procedure, you state that, oh, the limiter has been changed to this. Then you do create procedure. That's the syntax, create procedure. And then you name the procedure. So create procedure as get employee full details. So I want to get the full details of employees. Then you open a bracket and you put in employee ID. Now, what this means is that in employee ID integer. So now what this means is that we are we are creating this procedure, yeah, so that we can use this employee ID to call out this whole procedure. Now you see what I'm saying. So create procedure, the name of the procedure, then in employee ID. This is doesn't have to follow anything. You can name it anything, yeah. Employee ID integer. So we are saying the employee ID is an integer. So we begin the procedure and we say select, we do our normal syntax, select employee ID, first name, last name, age, gender, occupation, salary, and department name. We get it from employee demographics. We join it with salary. We also join it with tax department because all these columns are under these tables, and so we have to join. Where employee ID. So this is where it comes in. So where employee ID under the employee demographics table is equals to this EMP ID that we already defined here. So we're saying that employee ID here in this syntax is equals to this employee ID that we defined here. And then we end our our procedure. And instead of putting a semicolon as we usually do to end it, we use this this delimiter that we already defined here. And then we go back, and then after doing that, we then go back and say, oh, delimiter has been changed back to this. The only reason why we change delimiter to this is so that it doesn't give us an error. Because when you put a semicolon here, you put a semicolon here again, the syntax it gets, my SQL might get confused that, oh, you've ended the syntax here. Why are you ending another syntax here? So in order for it not to get confused and not to give us an error, we first define a delimiter to be this. We do our thing, then we finish the syntax with this delimiter. Then we also define that this delimiter has been changed back to this. So the syntax starts from here and it ends here. The real procedure starts from here and ends here. But we cannot just leave it delimiter like that, because if we leave it like that, that means for every code, every syntax that we do, we have to start using this delimiter, and we only need it for this syntax. So that being done, we're going to do this procedure. We're going to run it, so we see what we're talking about. So it has been successfully created. Create procedure. We've created our get employee full details. So what we're doing now, because what we explained or what we defined in the procedure was that employee ID in the demographic should be equals to this. So when we want to call it out, we'll call employee, we'll call the name of the stored procedures that we just did, which is get employee full details. And in the brackets, we're going to say one. Now, one means the employee ID. Now, one means the employee ID. So we are saying one, which is employee ID, is equals to this EMP ID that we define. So all these things is defined under EMP ID. So whatever we want, if you, for example, want to see full details of the first employee, which is one, it's going to give us that. We're going to get employee ID, first name, last name, age, gender, occupation, salary, and department name of the first employee. So instead, when you want to check for the second employee, instead of doing this same thing and then putting where employee ID is equals to 2, you just call for it and put 2 in it. So we're going to get for run, which is the second, the employee ID is the second one. When we call, you can keep doing that, yeah. And this is because if, for example, this is a syntax or this is a query that you do over time, you do a lot. So instead of keep copying and pasting or writing and saying, oh, where employee ID is equals to 1, is equals to 2, is equals to 3, you can just call for get employee full details because you've already defined this whole syntax as this. So please, if you understand, please let me know. If you don't, I can go over it again because it can be a little tricky, but I can go over it again if you don't understand. But if you understand, let me know. So I know that you're following. Excuse me, I think I heard a sound. Oh, okay. Somebody joined again. So let's go back to that. We created a procedure to be this. This is the name of the procedure. And we said we're creating the procedure in the employee ID, which we defined as EMP ID integer. We're also doing it, in this first procedure, we only did for one employee ID integer, but we're doing it for in two places now, in employee ID integer and in new salary decimal. So we begin and we update our employee salary and set salary. We are updating the table employee salary and we are setting the column salary equals to new salary. This new salary that we defined in this procedure, we are setting salary as new salary. So anywhere there is salary, it equates to new salary, and anywhere there is employee ID, it equates to this EMP ID that we defined here. We put our semicolon to end it, and then we end the whole syntax, and we use the delimiter, and then we define that delimiter has been changed back to a semicolon. So let's do that and see if we're on the right track. And bear in mind that Ron's salary was 70,000 before creating this procedure. The procedure is created successfully. And so what we are doing here is we are updating. Yeah, this procedure is to update salary. So anywhere there is salary, we are going to update it as new salary. And anywhere there is employee ID, we are going to update it as this. So call, to execute a procedure, we use the syntax call. So we call the procedure name that we created. And in brackets, this employee ID, we say it is 2. Remember, we already equated employee ID as EMP ID. So EMP ID, we want it to be 2. That means our employee ID is 2. And then salary, our new salary, which is the salary that we set, is 65,000. So let's call that. So we've called that now, and the next thing to do is to select all from employee salary, and let's see if it has been updated. So as you can see, This is why I said you should take note so that we see if it has been updated. Ron's salary was 70,000 and now it's 65,000 because we already used the stored procedure to update. So stored procedure can retrieve data, it can also update data. So that's just basically what this example was showing us or is showing us. So the next one we are going to do is employee counts by department. We've done that in views, but we can also do that in procedures so that we can get, oh, we might be interested um how many employees are in each department. We just want to see how many employees are in each department. So of doing the syntax all over again, over and over again, we can just call for each department and see how many employees are in them. So like we always do, we start with the delimiter change, we create procedure, and we name the procedure, get department employee count in department ID integer. So we begin our syntax as select department ID name, the count of the ID as employee count, from employee demographics as D, join it with the employee salary. We also join it with the department, where department ID is equals to this that we defined here. And we're going to group by department ID and department name. We're going to end our syntax as this because we already defined delimiter as this, and then we define delimiter back to a semicolon. So let's do this. Syntax starts with this and ends with this. Great. So we have this. We've created our procedure. So we're going to call. So when we call one, we mean that department ID, which we said is equals to department ID impacts department, impacts table, means that when we call for one, it means that it is the first department ID. So let's call for one here. So you can see that the first department name is Bolo Parks. Yeah, and it has 7 employees in Bolo Parks. Let's call for another. So this one is calling for department ID 6 because your department ID is equals to what we defined here as department ID. So we're calling for department ID 6 and we only have one employee in department ID 6. So this is just basically what stored procedures are about. Yeah, they store a procedure there, and we can always call for um, different kind of values to see their different answers. You don't have to keep typing this every time, keep querying this all the time. You can just call for a value and then we'll know the corresponding answer. But we can update. You don't doesn't have to be data retrieval all the time. You can update also. So that being said, let us go back um to our slide. So the next thing on slide is triggers. I hope you can finish this before this call goes off. If not, we'll have to. Okay. If not, we'll have to open up another class. Class ends in 5 minutes. So let me just run through what a trigger is. So maybe when we come back, we'll just do triggers in our MySQL interface. So triggers in SQL are special type of stored procedures. Now they are stored procedures, but they automatically execute in response to a specific event on a table or a view. Now triggers unlike they are stored procedures here, but they are not just stored procedures. They automatically execute themselves in response to a specific event. So we have to link it to a specific event that, oh, when this happens, do this. When this happens, do this. So they are automatic, and that is very good because it saves us time. It saves us, doing things over and over again. And unlike stored procedures, which must be explicitly called, triggers are fired automatically when certain conditions are met, such as when a data is inserted, updated, or deleted. Now, the basic syntax for triggers in my SQL is create trigger. Now, key features of triggers are that they have automatical execution, like I said before. Triggers run automatically when a specified event occurs on a table or a view. So they are automatic. You don't have to call for anything. Once that thing that you specified occurs, it will execute by itself. It is event driven. They are linked to a specific event, such as data modification. Triggers can be created to fire before or after an event occurs. So it is event driven. It just doesn't occur. It occurs when what you linked it to has happened. So enforcing business rules. Triggers are very, very, very useful and they are commonly used to enforce business rules. They maintain data integrity and they automate processes like logging or auditing changes of data. So, like I said, enforcing business rules is something that triggers are used for a lot because instead of you know what your business questions are, you know what you're trying to get all the time, you know what you're trying to update in. Because most of the time, in fact, all of the time, you design your database based on your business business wants, yeah, business questions. You cannot just design a database. You're designing it because you want something for your business. You want to answer questions, yeah. You cannot just design it because you just want to design a database for fun. So, like I said, is enforcing business rules. Triggers are used when this happen. When this happen, it's it triggers what you have already linked to it. Or when I update a for example a department name now, yeah, it triggers an automatic run or executes it automatically. The last one is trigger type. So there are typically two main types of triggers. There are before triggers and after triggers. So let's go on. Or let me just see if okay, Ajay, did you raised your
Yeah,
hand?
I was trying to say that the call is almost like ending. So like, can you just share another link so that
Yeah, of
it doesn't
course.
really
That's what I said
disrupt
before.
the
I
learning?
was going
Okay.
to do that.
Okay. Thanks.
Thank you. It ends in 2 minutes. All right, so we're going to end the call or the meet, and then I'm going to send another link. Thank you. So it's saying the foreign key constraints fails because you can't reference the department ID impacts department. Still having the issue. And if this is okay, it means that the connection is okay. So
Meanwhile, when you like your insert statement, like, are you meant to, since you're already making reference to that table, are you meant to still like manually populate the department ID,
I just
or
did that because it's easy to do right now because it's just um 12 values. But obviously if it's like a bigger data, you would have to update it. Yeah, but since we use the drop database if it exists and we're doing it from the beginning, it doesn't it's no issue since it's like we're creating a database all over again and we're doing all of this all over again. So there should be no issue really. But there seems to be. Okay, I think this
and
is
there's
an
no
issue.
department ID too?
There's no what? What did you say?
There's no department ID too. You said it's auto increment, so that means there's meant to be something that should be in department two. One of the employees should be in department two, but there's no two here.
Some people are not in the departments. It's not. There is no two. There is no five.
So people are
There
not
is
in
no
the
seven.
department.
Mm. It's random, so doesn't really matter.
Okay, so that means it's not. That means it's one or none too many. No, that's, yeah, one to one or none. Uh,
Let's see how it goes again. Still an issue. Mm. The foreign key department ID. Tax department ID. Okay. Okay. I think it will work out now. There was nothing to connect to. Oh, wow. Okay, Bolu Parks.
so here, so what I'm saying is that that Pax ID is auto increment. That means automatically there will be there will be that like this blue Pax now is one, animal control is two.
Yes.
Yeah, so the data you're providing would also have to map that pattern. So if it goes through and you see that there's no two, there won't be a way for them to have that connection because automatically this is a primary key that does not change. So what you are providing to also need to have those instances of that
I
key
don't
there.
think that's the issue because we've done it with employee salary and it didn't have
Wait,
any issue.
employee
Employee, can
share,
you
let me
see?
see.
It? Employee salary had department ID 1111436434. You get my point?
And you
Yeah, we've been using it since
and you,
now.
you
It wasn't
reference it the
an
same way, yeah, with different
yes.
constraints.
I copied. That's what I copied to
Mm,
the. So that was
okay.
not. That's
So
not the
what,
issue.
what what did you change now?
The error now is what I did was to insert into Parks department before inserting into before inserting into employee demographics. So it has something to connect to. But the error it's
Yes,
giving me now is the field employee ID does not have the Bolu Parks is having an issue with the Bolu Parks. Field
doesn't
employee
have a
ID does not
default
have a
value.
default value.
Employee ID. I guess maybe for, let me see, default constraints is a placeholder for a table that does not have a particular attribute.
Okay, we have employee ID here. Okay, I think that's the issue. We changed it from putting department ID in employee demographics to putting employee ID in parks department, right? Right?
Yeah, I guess I
I think we need to delete this.
but this okay because this employer ID they are making reference to go. I don't think you need the not constraint again on it. Have you?
There's always a constraint between foreign and primary keys.
Yeah,
Always.
yeah. That's why I said like another constraint again because it is. I
So
think
what
I
we're
know.
doing now, we're putting
Ah,
the
sorry.
employee
I
ID
need to
in the
quickly.
parks department. I feel like we've done a wrong connection somewhere. You know what? I feel like we'll do this some other time because it's taking so much time. Yeah, this is like literally 3 hours or 4 hours after. So I might have to just do it and then give feedback on how it went. Because if we start to troubleshoot errors, we'll spend time here. So let's just disperse now and maybe some other time we can have a meet and know what happened to it. Hamid is clapping. All right. Yes. Yes. I think that's what's going to happen. All right. Thank you. Thank you, guys. Thank you so much.